Welcome guys. In this video we are going to look at question 3 of math paper 2 for the year 2022 for the GCE. So question 3a is about the set. So let's look at this question carefully. So the question reads, in a particular locality 25 people like walking, 22 people like running, then 15 people like cycling during their daily routine exercises. 11 people like both walking and running. 9 people like both running and cycling. 7 people like both walking and cycling. 3 people like all the 3 activities, while 7 people do not like any of the activity. Draw a Venn diagram to illustrate this information. So we have started. So whenever you're told to draw a Venn diagram, you start by drawing a rectangle. So I can put letter E here. Now, how many sets are we going to write? So 1 for walking, running, and cycling. So 3 sets. Now, do you have the intersection of the 3? Yes, we do. This statement here, 3 people like all the 3. So it's very important you identify this. Now, since this is the case now, when drawing the 3 circles, make sure they intersect at one point. They have to intersect. All the 3 must intersect at one point. So for walking, I'll put W, running R, then cycling a C. Step number 1, first indicate those that did the 3. So from the given statement, we are told 3 people like all the 3 activities. So this 3 is part of those that did 2, is also part of those that did like walking, as long as there is no only. Now, after you have indicated those that did the 3, you need to look at now those that did 2. 11 people like both walking and running. Walking and running is this region. We are told how many? 11. Now from that 11, we already have a 3. So you are supposed to subtract. Don't indicate the 11 here, no. Because we already have a 3. So you say 11 minus 3, you put 8. Which means that out of 11, 8 did walking, 8 did running, 8 did both walking and running only, then 3 did the 3. Right? Let's move on to the next one. 9 people like both running and cycling. So we have 9 at this region. Now from that 9, you subtract a 3. So which is giving us a 6. So to show this region here and here, you subtract from the intersection of the 3. Now we have 7 people like both walking and cycling. So 7, we subtract a 3. We have the total of 4. Now after this is done, we need to go back to the numbers. Like 25 people like walking. So how many? 25 people like walking. So what I'm going to do is I'm going to get my walking, then I equate it to 25. So the total number of people in this group is 25. Now from this walking here, I'll just put an X so that we have X representing the number here. Then we have 8, as we can see, is part of walking. 3 is part of walking. Then 4 is part of walking. So I've just gotten the numbers from the W, all the numbers that I can see, as long as they are part of W, because I want to come up with an equation. So I'll say X plus 8 plus 4 plus 3 then is equal to 25. So X is representing the number of people that liked walking only. They did do any other activity. So I have X plus 8 plus 8 plus this one is 12. 12 plus 3 we have 15 is equal to 25. Then I can shift my 15 to the right side, giving me 25 minus 15. Then my x is equal to 10. So the value of x is 10. So we are going to do the same for us to find the number of people that did the running only. So I'm going to come up with the same vision. So this is for running. So I'll put x for those that did running only. 8 is part of running, 3 is part of running, 6 is part of running. Then we are told 22 people like running, so we equate to 22. So I'm going to say x plus 8 plus 3 plus 6 is equal to 22. Then x plus 8 plus 3 is 11 plus 6 is 17 is equal to 22. We shift this number to the other side. 22 minus 17. So x is equal to 5. So that's our value here. Then we can now do the last one. So this is for cycle. So cycle, 4 is part of cycle, part of C, 3 is part of cycle, 6 is part of cycle. Then we put x here. So the x we know represents those that did one activity only. So I'm going to say this is equal to 15 people like cycling. So it's equal to 15. So for equation, this will be x plus 3 plus 4 plus 6 is equal to 15. So 6 plus 4 is 10 plus 3 is 13 is equal to 15. If we shift this to this side, we are going to get 15 minus 13, giving us a 2. So that's a value of 2. Now, the remaining part here is, do we have those that didn't do, or those that didn't like any of the given activity? So we are told 7 people do not like any of the activities. So the 7 must be written anywhere but outside the sets. Right, we move on to now Roman number 2. How many people are in this locality? So to find this, we need to add all the numbers in a Venn diagram. So I'm going to start with 10 plus 8 plus 4 plus 3 plus 5 plus 6 plus 2 plus 7. So 10 plus 8 is 18. 18 plus 4, that is 22, plus 3, that is 25, plus 5, that is 30, plus 6, that is 36, plus 2, 38, plus 7, 45. So I'm getting the total 45. So there were 45 people in this locality. Then for B, like walking only. So the region for walking is here. Now from the numbers that we have, which one refers to those that did walking only? So if you look at 8, 8 is part of W and R. 3 is part of W, R and C. 4 is part of W and C. Then 10 is the only number in W only, so we just say 10. So remember, 10 did walking only, 5 running only, 2 cycling only. Now for question C, we just want those that did 2 different activities. So as long as there's only 2 different, so 4 did walking and cycling only. So we say 4 plus 6 cycling and running only plus 8. So 4 plus 6 is 10 plus this one is 18. So this is how we can find this answer. Right, so we move on to question B, where we're told the position vectors of the 3 points A, comma B and C are -1, -2, 3, 6, and 9 and 18 respectively. Show that the points A, B, and C are collinear. So the collinearity in terms of this tells us that the 3 or whatever number of coordinates or point that you are given lie in the same straight line. So we want to prove that if we have, let's say this is point A, then this is point B and this is point C. So we want to prove that the 3 points lie in the same straight line. There are different ways, but what we are going to do is I'm going to use the slope format, finding the gradient. So let me find the gradient between A and B. So my point A is -1, -2. Then my point B will be 3, 6. So let's find the gradient. So this gradient that I'm finding is the gradient for line AB. So I want to find the gradient for this. So to find this, I'm going to say x1, x2, y1, y2. So gradient is equal to y2 over y1, sorry, y2 minus y1 over x2 minus x1. So y2 is 6 minus y1 is -2 over x2 is 3 minus -1. So we know that negative times negative is positive. 2 over 3, negative times negative is +1. So 6 plus 2 is 8. 3 plus 1 is 4. 4 into 8 will give us 2. So the gradient for line AB is 2. Let's check for AC. What if we want to find AC? So remember, A is still -1, -2. Then C, 9, we have 18. So 9, 18. Let me put them in coordinates form. 9, 18. As usual, x1, x2, y1, y2. So gradient for AC will be y2 minus y1 over x2 minus x1. So what's our y2? 18 minus -2 over x2 is 9 minus -1. So negative times negative is positive. So we have 18 plus 2 on top over 9. Negative times negative is positive. So 18 plus 2 is 20 over 9 plus 1 is 10, giving us the gradient of 2. So we've seen that these points are collinear because they are giving us the gradient of 2. Then the last one, if you want to prove, you can check the gradient of the line, the points B and C. So if you check for B and C, you still get the gradients of B and C is equal to 2. So as long as they are giving us the same gradient, then we can say the points A, B and C are collinear. Or if you want, you can find by you add. Let's say you get A plus B, you get the final answer. A plus C, you get the final answer. B plus C. You still, if you are getting the same result, then the lines are collinear. So that's it for this video. Thanks for watching.